All right, here we are on 6.3 on the dual problem, and this is minimization with problem constraints in the form greater than or equal to. So a little different than the last section on less than or equal to. All right, so here we're supposed to form the dual problem from this minimization, where I write the initial system for the dual problem, then write the initial simplex tableau for the dual problem, and label the columns of the tableau. We don't have to solve it. So first things first, we start with the minimization and those greater than or equal to subjects to things. What we need to do is we need to first write our A and then find a transpose of those matrices, and then after that we can write the dual problem. After that we can convert that to the E system, and then after that we can write to the simplex tableau. So first things first, A. Well, A is just going to be the matrix 2, 1, 7, 3, 1, 9, and then our 12, and then a 5, and then a 1. And so this is what it looks like. And usually for convention, we have that. And again, so these are our basically our, where's my writing stick? X1s. This is my X2s, and that's going to be my A. Now, I do a transpose. And that just means I convert whatever's in this first row down to the first column. So then that becomes a 2, 1, 7. And then I have a 3, 1, 9. And then I have a 12, 5, 1. And so this is now my A transpose. And these are labeled Y1, Y2. Okay, so we start with X's, convert to Y's, and so now when we write this, we can go A transpose and we can write our dual problem, and we just read across. So that's 2y1 plus 3y2. And now when we did this transpose, it's now less than or equal to 12. And then we have y1 plus y2, oops, is less than or equal to 5. And we have our p is going to be equal to 7y1 plus 9y2. Now we convert that into our E system, which means we get rid of our inequality, make an equality. But remember, here we're adding the slack with the x's, so it's going to be some xi's, and so we have 2y1 plus 3y2 plus x1 equals 12. And we have a y1 plus a y2 plus x2 equals 5. And we take those to the other side. So we have a minus 7y1, oops, minus 9y2 plus p equals 0. And we have all of our things as usual, our y1, y2, x1, x2, all greater than or equal to 0. Okay, so that's kind of be our E system. And again, what happens is when we get the answers, our slack variables are going to become our solution to the original kind of problem. Okay, so we start with the max, a minimize, and now we're kind of into the maximize kind of looking type problem. And so then we're going to work our way through that. And so since we don't actually have to solve this, let's go ahead and write the tableau here since it's not needing to be solved. So we have a y1, y2, x1, x2, P, and we might get everything in here. And then our X1, X2, and P. And so now we have a 2, a 3, a 1, a 0, a 0, a 12. And then we have a 1, a 1, a 0, a 1, a 0, and a 5. And a minus 7, a minus 9, a 0, a 0, a 1, and a 0. Okay, so that would be our kind of our initial tableau, and that's what they're asking us to do. That's our initial simplex tableau, and then from there we would do other stuff. But for this problem, this is all we need to do. Okay, all right, so let's stop there, and then we'll come back for another problem.